In the Beginning by Dr. Walt Brown, page 229. Evidence requiring explanations. Summarized below are the hard-to-explain details that any satisfactory explanation for the origin of Grand Canyon should answer. Layering. Probably the most striking sight at the Grand Canyon is the vastness of the parallel sedimentary layers, multicolored in their differing material and chemical content. Any explanation for the Grand Canyon's layers should also explain other sedimentary layers worldwide because they are so similar, although less dramatic. Limestone. The Hualapai limestone west of the Grand Canyon was deposited before the Colorado River flowed out the western end of the Grand Canyon. Also, many layers in the canyon consist primarily of limestone hundreds of feet thick. What is the source of so much limestone? And what concentrated it? If these limestone layers were deposited in shallow inland seas, the standard explanation, then the Colorado Plateau had to rise and fall at least once per layer. Explaining one lift is difficult enough. Marble Canyon. How does the origin of the nearly straight Marble Canyon and its narrow vertical walls relate to the origin of the adjoining but broader Grand Canyon? What accounts for the strange patterns of tipped layers in the walls of Marble Canyon and Echo and Vermilion Cliffs? Distant cavern connection. How could a deep and dry underground cavern develop 5,400 feet above sea level and have an underground channel that drains into the Grand Canyon 63 miles away? Side canyons. Why do so many dry side canyons enter Grand and Marble Canyons at depths of the Colorado River? Barbed canyons. Why does Marble Canyon have large, barbed, backward side canyons that enter the Colorado River at such surprising and large angles? Slot canyons. How did such narrow side canyons with jagged walls capture enough water to cut deep channels that drain into the Colorado River? Why are most of the world's slot canyons on the Colorado Plateau? Perpendicular faults. Why are the dozens of faults in the Grand Canyon generally perpendicular to the Colorado River? And why doesn't the river flow along an easier path provided by a fault? Maybe the deep erosion that carved the canyon produced the faults. Arching. Why are Grand and Marble Canyons cut down into and along the top of a broad, upward-pointing arch that spans most of their 277-mile combined length? Inner gorge. Why are the walls of the inner gorge so deep, steep, narrow, and rough? How could a river cut so deeply into such hard rock at the inner gorge, but not as deeply into softer rock both upstream and downstream? Nanquip Canyon. Why did humans live for centuries in this dry, desolate canyon? What produced the avalanche and provided a violent, multi-directional flow of water able to, 1, carve Nanquip Canyon and its side canyons, create a large delta that remains today despite the cross-flowing Colorado River, and 3, stack thousands of large, rounded boulders 100 to 200 feet high along Nanquip Creek? Where did all the water come from? Where did all this water come from? Unusual erosion. Why are slumps, landslides, and rockfalls found on the top of Nanquip Mesa? Why does the Colorado River sharply delineate this eroded region to the west from the smooth lower region to the south? Why does the Colorado River sharply delineate this eroded region to the west from the smooth lower region to the south? Forces and mechanisms. Any explanation for Grand Canyon requires lifting the Colorado Plateau more than a mile in the air and excavating and transporting thousands of cubic miles of rock. Are the forces, energy, and mechanisms for these movements known or merely inferred or assumed? Without a knowledge of the underlying physics, which must conform to scientific laws, major errors can creep in. Even if the inferences or assumptions are correct, ignorance of the actual forces, energy, and mechanisms will blind us to root causes, rates, and other consequences. Predictions will not present themselves modeling and testing. Predictions will not present themselves. Modeling and testing become limited. Such half-baked explanations simply confuse others. Why here? Why is the Grand Canyon where it is? And why are there not many other Grand Canyons worldwide? The canyon receives little rain. If an explanation claims that over millions of years, a set of conditions such as fast-flowing river produced the Grand Canyon, then dozens of other Grand Canyons should exist where those conditions are even more extreme. Why so recently? If the Colorado River carved Grand Canyon during the last 1,000th of Earth's history, why didn't more powerful rivers carve other Grand Canyons? Missing river. Limestone was deposited at the western end of the Grand Canyon before the Colorado River flowed through the canyon. Where was the river? What brought it to its present location? How was the western Grand Canyon carved? Missing talus. In the canyon region, why do tall cliffs such as Echo Cliffs, Vermilion Cliffs, and others have little talus, rubble, at their bases? Kaibab Plateau. Why and how did the Colorado River make a right turn and cut up through the Kaibab Plateau, which rises more than a mile on either side of the river? What caused the Kaibab Plateau to bulge upward like a squeezed water balloon? Colorado Plateau. A plateau is a large region whose horizontal sedimentary layers were lifted relative to the corresponding layers surrounding the plateau. The Colorado Plateau rises an average of 6,200 feet above sea level. Can you see why the 1 mile deep Grand Canyon would never have formed on land that is less than a mile above sea level? So what lifted the Colorado Plateau? For all its glorious views, the Colorado Plateau remains an ugly mystery to geologists. They can't figure out why and how it rose thousands of feet over the millions of years it took to carve spectacular natural wonders like the Grand Canyon and Monument Valley. Missing Mesozoic rock. What swept off the soft, 1,000-foot thick Mesozoic layer from atop 10,000 square miles of hard, horizontal Kaibab limestone? How could that layer have been swept off the much higher Kaibab Plateau? Missing dirt. The carving of the Grand Canyon removed about 2,800 cubic miles of dirt, and yet the Colorado River's delta does not contain even 1% of that dirt. Where did it go? Was there enough water to transport all that dirt? Fossils. Why are fossils found only above the Great Unconformity? Tipped layers. Why are sedimentary layers, hundreds of feet thick, tipped at steep angles below portions of the Great Unconformity, while the layers above, averaging 4,000 feet in total depth, are horizontal? Time or intensity. A satisfactory proposal for carving the Grand Canyon must show in a self-consistent way either that eons of time transpired or that there was a violent flow of water. Okay, figure 125. Oh yeah, we read this one already. Grand Canyon in 3D. Yep. The Colorado River lies below the dashed blue line. Obviously, a river did not carve all that randomly oriented drainage channels that make up the Grand Canyon. Much more water was involved, and yet for 150 years, the public has been told that the Colorado River carved the canyon over millions of years. No wonder that explanation has so many recognized problems, even in the eyes of the so-called experts. Surface water typically flows downhill. However, the flow of subsurface water depends in part on the location of faults and other subsurface drainage channels. Sediments deposited on the continents by the flood averaged more than a mile in depth over all the earth. Each grain that settled through the muddy floodwaters helped trap water between the loosely packed grains. When the flood ended, approximately 20% of the floodwater was temporarily held between sedimentary grains, seeking ways to escape to the surface. Water that did escape accounts for many of today's land features, including much of the Grand Canyon. The dashed yellow line shows part of a 60-mile-long Bright Angel Fault, as figure 149 on page 157 explains. Figure 149. Okay. Figure 149. We are looking south at the Bright Angel Fault, shown by the dashed yellow line. Note the vertical offset of the two broken segments, almost white segments of the prominent. Okay. Uh-oh. Here we go. We're looking south at the Bright Angel Fault, shown by the dashed yellow line. Note the vertical offset of the two broken segments of the prominent, almost white, 400-foot thick Coconino sandstone layer. Imagine the gigantic force that fractured and lifted many horizontal slabs of the thick rock along the dashed yellow line. The fracture extends some distance into the south rim of the Grand Canyon, in front of the camera, and 60 miles to the north behind the camera. Now try to imagine a 300-mile-long train loaded with the weight of the 2,800 cubic miles of dirt eroded from the Grand Canyon, plus enough water equal to the volume of 2 Lake Michigans and 1 Lake Huron to sweep that dirt 400 miles to the Gulf of California and then far into the Gulf. The train is traveling west along the path of the Colorado River flows today. The depressed ground below that heavy train springs back up when the train spills over the western edge of the Colorado Plateau that centuries earlier was filled more than a mile. For every pound of dirt and water that the stupendous waterfall an additional pound of upward force acted to shear the slab and produce the fault. That rebound and vertical vibrations were greatest at the western edge of the plateau, so the horizontal slab sheared along the dashed yellow line, and the west side of the fault was lifted 300 feet higher than the east side of the fault, allowing groundwater to spill out and erode much of the path that years later would become Bright Angel Trail down to the Colorado River. This dramatic fault and the break and offset of the white Coconino sandstone layers are easily seen by looking across the canyon from the north rim. Okay. So the dashed yellow line shows part of the 60-mile-long Bright Angel Fault. Page 257, the yellow line, 60-mile fault. Grand Canyon Village. Okay, been there. Right on that fault. As the figure on 149, page 257 explains, the west side of the vertical fault, a deep fracture, rose 200 feet higher than the east side, allowing subsurface water to escape out of the freshly exposed 200-foot high cliff face and up out of the fault. That erosion carved the prominent Bright Angel Side Canyon, the location of the famous Bright Angel Trail. Hundreds of less spectacular faults account for hundreds of other variously oriented valleys and side canyons that allowed escaping subsurface water to drain down to the deepest channel, where the Colorado River now flows. In other words, Grand and Hopi Lakes water eroded the Grand Canyon first, then the region's natural drainage created today's Colorado River, just the opposite of what most geologists and the Grand Canyon National Park rangers tell us. Next will be proposals for the origin of Grand Canyon. This is In the Beginning by Dr. Walt Brown. Evidence that requires an explanation.